All right. When we talk about complex, sometimes they're also called imaginary type numbers. This is what's called standard form, a plus bi. There's an imaginary part that has the I, and there's a real part that's just a plain old number. Okay, and we'll get into more of that as we actually are breaking some of these down. But the part that's more helpful on this sheet is what we have down below here. Before, if we had a negative number under a radical, we'd punch it in the calculator, it'd say error, we'd say no solution, we'd go on. But there actually is a solution. It's called this wonderful thing called the unit I, which stands for the square root of -1. Now we'll talk a little more here in a minute about how I can actually use this to start simplifying answers. But these are the 4 different values you can get for I, and that's important because there's going to be some times today that we're looking for like I to the 37th power, I to the 62nd power, and we don't want to have to do every single one of these counting up. So we're going to find some patterns. When you look at I squared, you're like, oh, that's basically me just taking I equals the square root of -1, and if I square both sides, I squared and square root cancel and get me -1. If I went to I to the 3rd, again, just think of that as I squared times I. So I'd have -1 times I, which is where this negative I comes from. So it's just kind of seeing where the origins of these come. I to the 4th is 1. Well, that makes sense, because I squared times I squared would be I to the 4th, and we know that I squared is -1, and negative times negative is positive. Once you get past that 4th option, when you go to I to the 5th, okay, I to the 5th would come back here to where I is at. I to the 6th would go to where I squared is at. And the pattern would just keep developing and going round and round and round with this. And you can see why it would be helpful to kind of understand, oh, I kind of see how there could be a pattern that develops with these. So if you do get like I to the 150th, you're not having to sit there and go 1, 2, 3, 4, 5, 6, 7, 8, and do it all the way up to 150. And we'll talk about some patterns that'll let you figure that out, again, as we get into some of the problems on the note sheet. But this is something that's handy at the start to kind of let you help you out when you're starting to work some of these. But these are 4 things you probably want to get into your memory bank because it'll help you out a lot when you're not wanting to do a whole bunch of work for a quiz or a test. Now, I talked a little earlier about some extra credit being available, and that would actually be on the back of this sheet. Except I can't show you the back of this sheet because that's my answers. So let me come back over with a fresh one. On the back here, once we get done with today's notes, this will make more sense. But what you can do is you can complete this maze, and what you would do is you'd solve these. And the ones that have imaginary numbers, the answers that have I in them, you'd start here, and once you've solved them, there's going to be like this pattern or this maze that goes through here from start to end, and all of your answers that are imaginary will make this little guide like you're going through a corn maze or something. And so that's something we are going to say is going to be extra credit for this upcoming homework check if you want to play around with this. Okay, that's going to be an option. But like I said, this will make more sense once we get through these guys a little bit. So, okay. Complex numbers. Again, we talked a little bit about what this I and this I squared is and things like that. So since we talked a little about that before, I'll leave this to you if you need to go back. And then we've got the running total here, sort of like we did on the sheet over there as well. So when I go to break these down, and y'all know I do some strange stuff, and it's going to get even stranger this week. This is my oddball week. For instance, okay, here I've got the square root of -49. I type that in the calculator, I get an error message, but we're smarter than that. So what you've got to do is whenever you have that negative, you are going to pull an I out before you start. I mean, if you literally need to go Halloween graphic here, think about it like you're literally pulling your eye out when you're doing these. That becomes positive then, and hey, the square root of 49 comes out nice. That's just 7. So this is going to be 7i. But whenever you see that negative, Just keep telling yourself. Pull an I out. That gets all the negativity out of it. And if it happens to be nice, again, great. We'll go ahead, we'll break down the radical the best we can, and we'll go on with our business. Will the radical always break down? No. I can still pull the I out, but if I can't break down the radical that's left, I just leave it. If I could break down the radical more, I would, and we'll find some a little later in the sheet that I can. But for right now, that's all we've got. Here, squaring this, remember you're squaring the 5 and the I. So negative 5 squared would be 25I squared. But we remember, oh yeah, I squared is negative 1. So I just replace the I squared with its value and get the answer. And some of you will pick up pretty quickly, oh, so since I squared is just negative 1, whenever I see I squared, I'm just going to change the sign of whatever's in front of it. So like this 25 became negative 25. If this would have been negative 10, this would be positive 10. Exactly. So I is just something that lets us simplify things a little bit more. And again, we talked a little on the sheet about a complex number. Anything that can be written in standard form, where again, this is real and this is imaginary. So name the real and imaginary part. So again, real is going to be your constant term. And the imaginary part is whatever part has the I with it. And typically, unless something strange is going on, your real part will always be first and your imaginary will be second. Now here's where this gets a little more interesting. We get up to a problem like 7. When you're going to do it this way and you're naming the real and imaginary part, we need to get these split up. In other words, I'm going to look upon those as two separate fractions. And this time, the imaginary part was first because it has the I, and my real part's going to be second. So occasionally we may have to split things up a little bit to make this work a little better. But most of the time, we will not need to. Because again, just find that I and you have found the imaginary portion. So what else can we do with I? We can break down a radical, okay. We can label the parts, okay. What else can I do? Well, I also can combine it. It's sort of like combining like terms. We can treat I sort of like a variable term. Now, it's not a variable term. It actually has a value. But I can look and say, oh, so like negative 3 plus 6 is 3. 1I minus 3I is negative 2I. I don't see any I squareds that change anything, so I'm done. Right. And some of you may say, well, what if I put negative 2I plus 3? It's okay, but again, remember what our standard form is. Our standard form is the constant term, my real term, and then the imaginary part second. So we'd really like to stick to that. Now sometimes, again, the plus isn't going to do anything for me. So negative 8 plus 8, okay, that's negative 16. 5I minus 5I, oops, that's gone. So sometimes I'll just get a value. The part where this starts to get tricky, if you go too fast, is when minus gets in the middle and basically you're distributing that through. So like here, 2 minus 3 is negative 1. And negative 1I minus 2I is negative 3. It may even be worth changing the signs in here, or literally rewriting that next step if you tend to go fast and make silly errors on things. Same thing here on 12. It's sort of like looking at that negative as I'm distributing it through. Negative 7 minus 4 is negative 11. 2 minus negative 5, or 2 plus 5, is 7. You're like, yeah, oh, bless you. This is great. These are just rolling along. I'm just combining things. Then comes the part to be careful. When we get to multiplying, okay, we're going to FOIL this out, but we're going to have some things that are going to change, some things that are going to combine, some things that are going to take a little different of a look. So I'm going to write all of this out. So my first, I'd have negative 12. My outer, 3 times 2i is 6i. My inner, negative 4 times I is negative 4i. And last, I times 2i is 2i squared. But there's lots of simplifying to do here. For instance, a positive 2i squared, again, I'm just going to change the signs. That's basically going to become negative 2 because I replace I squared with negative 1. 2 times negative 1 is negative 2. And now I combine like terms. Negative 12 minus 2 is negative 14. 6i minus 4i is 2i, and now I'm good. So really the only difference between this and FOIL that we've done before is if you have an I squared, you know, it's going to change that value to negative 1. Here I've got a difference. Now again, if you notice it right away, you don't have to do the O and the I. But if you don't, that's not the end of the world. Because I'd go, okay, so I got minus 10i plus 10i, and we just talked about how they'll cancel. And then negative 4i squared, which again just means I'm changing the sign. That negative 4 becomes a plus 4 because I replaced the I squared with negative 1. And 25 plus 4 is 29. So again, all basic stuff we've done before, just with a new little twist. Now, this is the one where there's a little more caution. When you have multiple terms with negative radicals, we're going to break them down each first, then put them together. So for instance here, I'm going to pull my I out, and then here I'm going to pull my I out. Now at this point is where I can put them together. So I times I is I squared. 3 times 15 is 45. And now I go looking for things that'll simplify. For instance, I know 45 I can break down using 9 and 5. So I'm like, okay, square root of 9 is 3, square root of 5, and I squared is negative 1, which just means I'll put that negative on the back side, and I'll be ready and rared to go. So, okay. Now, some of you may say, couldn't I have just multiplied these together to begin with, instead of doing all this separate stuff? Well, here's the problem you would run into. If I'd have multiplied those together at the start, you'd have gone, well, negative times negative, it'd be positive 45. And then you'd break it down like we did, and you'd end up with 3 square root of 5. That's the issue we have. That's why we've got to break these down and get the i's out first. Because otherwise it'd be like pretending, well, the i's don't even exist. I don't even see them anywhere. So you always got to break down first individually, then go back and do what you can as a group. So like here, even though I want to multiply them right now, don't do it. Take your I out. 5i square root of 2. Take the I out. 2i square root of 16. Now, if you notice at this point you can break down one of the radicals before you multiply them together, you can. If you don't do it until the end, that's okay. Because again, both will work. Because here, if I were to multiply them together, I'd have 10i squared square root of 32, and you're like, well, I'm just going to break it back down anyway. It's 16 and 2 like I had before. Right. So I'm like, okay, square root of 32 would be 4 square root of 2. I squared is negative 1, so 10 times negative 1 is negative 10. And then I can put everything together. Now again, if some of you did the 16 right away and made it 4, and 4 times 2 would be 8i, and you did it that way, you'll end up with the same answer at the end. It would absolutely work. You just always have to deal with those negative radicals first. Once they're set, any order is going to work okay. Here, again, you have choices. Some of you may look at this and go, well, I squared is -1, so this is really just -3i times -4, which would be positive 12i. Or some of you, if you're trying to get adventurous, may say, if I multiply them together, I get -12i cubed. But then I go back and I go, oh crap, what does I cubed equal? I don't remember. I can either go to my big sheet or I can say, oh yeah, I cubed is -i. And negative times negative is positive. Whoops. I am off the screen. Excuse me. Oh, bless you. So if I went to the third and then I remembered that I to the third is -i, negative times negative, same answer. Again, lots of flexibility once those blasted negative radicals are gone. But I'll always have options as far as that goes. So let's see here. What else we got to play with? Oh, we had to know it was coming. We've worked before with radicals in the denominator, not being able to have those and having to rationalize them. We're going to do the same thing. So we're going to multiply by what now is called a complex conjugate, because now instead of just one term, there's going to be 2. So, similar to what we did before, all we're going to do now is the complex conjugate of any binomial is going to be basically just changing the sign in the middle. So since it's 2 minus I I'm trying to get rid of, I'm going to multiply both the numerator and denominator by 2 plus I. Because what you'll find out here is going to happen is that when I FOIL each of these out, so up here, let's see, I'd get 10 plus 5i plus 2i would be plus 7i plus I squared. Then down in the denominator, I've got 4 plus 2i minus 2i minus I squared. And you'll begin to notice, you're like, okay, well, let's see here. Up in the numerator, I squared is -1. So 10 and -1 is 9 plus 7i. And then I look in the denominator and I go, well, the 2i and the -2i in the middle cancel. That'll happen every time you multiply complex conjugates together. 4 minus -1, so this is basically becoming positive 1. 4 plus 1 is 5. Nothing goes into all 3 of those. And as long as there's not an I in the denominator, I'm good. That's the whole idea behind doing this. It's just changing a format so I can actually find a value that works. And the same thing is going to happen with any of these. Okay, if it's 1 plus I. I multiply by 1 minus I. Again, just change that sign in the middle. FOIL it out. Up top, there's going to be a little more to play with than down below. And down below, to be perfectly honest, if you're doing FOIL, you don't even have to do the O or the I because they're just going to cancel anyway. So if you just multiply your first terms and your last terms together, and you're like, well, minus I squared just becomes plus 1. You're like, what else have I got here? That's going to change plus 4 into minus 4. So 3 minus 4 is -1. Minus 7i. Again, nothing goes into all of them. But all I'm basically doing is FOILing, turning I squareds into -1s, and then combining like terms is all we do with these. You're like, well, wait a minute. Okay, understand here where it was minus, I did a plus. Here it was plus, I did a minus. There I don't see a plus or minus. Now what? Well, what we're going to do when this occurs is you actually have choices. Because it's not going to matter here if I multiply by 7i or negative 7i, because I times I is going to get me the I squared that I want, which in turn just means it's going to change the sign on that. When I multiply up top, instead of foiling, I'm going to distribute. 3 times 7i is 21i. 2i times 7i is 14i squared, but I know better. I know that I squared really just makes this whole term minus 14. But here's where I gotta watch it. Let me rewrite it in its form here and see what else might I be able to do. Is there anything that goes into all three of those terms? 7. So I'm going to divide each of those by 7. Now I'm done. Except for the fact that I was bad and did not write this in standard form, which is the better way to go. Not incorrect, just better. It's like better and best, if we wanted to look at it that way. All right, start throwing a couple of twists in and we'll have you ready to go here. Find the values of x and y that make the statement true. Okay, we're going to separate these into real and imaginary parts. For instance, here on 21, my real parts are the 2x and the negative 14. They don't have any i's with them. The imaginary parts are yi and negative 3i. I'm going to make two separate mini equations to figure out the values. So in my reals, 2x equals, negative 14. I can divide by 2, get my negative 7, so there's my x. With my y, I look and I'm like, well, yi equals negative 3i. Well, both sides have an I, so they cancel. Y is negative 3. I'm good. So again, just divide them into the real parts and into the imaginary parts, set them equal like you would any equation, and then just find your values. So again, nothing too terribly awful working here. The equations. Oh, now remember here, equations. Reminder, when we're solving quadratics, you're going to get two answers. I need to isolate my x squared, isolate my quadratic term, and then do my square rooting, but not until that's isolated. So those wipe. Pull an I out, along with my plus and minus, because I'm not forgetting there's two answers. Plus and minus I square root of 5. But just keep telling yourself, I must isolate. Must isolate. Can I square root yet? Don't do it. Divide by that 4 first. Once you have that under control, now you're okay to do the square root. Now I can do plus minus and pull an I out and be okay. But not until that's isolated. One last one here on 25, because then I want to play with the fun ones here. Again, isolate. Still not isolated, so divide by my 7. And here's where I've got to watch it a little more. Because it hasn't happened yet in the other ones, doesn't mean it's not this time. Before you circle something and say, that's my answer, I'm good, make sure, can you break down the radical? Because if you can, I need to. So here's how this writes itself out. Whatever breaks down, in this case the 4, goes outside with your I, and whatever doesn't break down stays underneath the radical. And that's all I'm looking for here. Now, and we talked before, when we had the big sheet out before, about how to deal with these guys. Basically, here's how this is going to work. Let me grab the one we were playing with earlier. Here's the rule I like to use with these. When you're trying to figure out which one it is, normally I'll go ahead, I'll divide it by 4. If it goes in evenly, it's going to be that one. Because if I were to count around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I could do that and end up back here. But if 4 goes in evenly, that also lets me know what this value is going to be. So if it was I to the 24th, it's 1. I to the 28th, it's 1. It's a multiple of 4. When I get to one like 31, I'd go, well, that doesn't go in evenly. You're right, it doesn't. Here's how I like to look at them. Okay, it goes into 4. 4 would go in 7 times, which would basically be, get me around to 28. 29, 30, 31. So basically, it's whatever multiple of 4 is going to be closest, or some of you might say, well, could I go to 32 and go backwards 1? Sure, that would work too. But work off that multiple of 4, and then you'll always be within 3, instead of having to count like I was about ready to do with 31. That's kind of ridiculous. But I could do it that way if I wanted to. And finally, and no, you do not have to be an electrical expert to be able to do these problems with electricity and voltage and current and impedance. I certainly am not. That formula, though, I need to be able to know to play with. So my voltage equals my current times my impedance. Find the voltage in a current with this many amps and this many ohms for my current and my impedance. So basically what I'm going to do here is I'm just going to multiply those together and simplify what I get. Now, here's the one thing I really want you to think about, though, because I'll warn you, the problems that you're going to do, sometimes they may ask for the current, sometimes they may ask for the impedance. You may have to wiggle these around a little bit. Like, for instance, if they ask for the impedance, and I wanted to get I alone, I'd divide by C. So that would change the way my formula looks. If I wanted to find the current, I'd divide by the impedance. So you have to be willing to be able to adjust a little bit to make these work, but sometimes it'll be easier than you make it. The current in one part of a series is this. The current in another part is this. Find the total current. Well, in this case, I just have to add them up. And then I would combine like terms and I'd be done. So there's lots of little things to do here. A little bit here, a little bit there. We kind of play with it. So the assignment at the bottom, because I always try to keep you guys straight with what these are. So homework check 7. This is final assignment number 4. If you haven't been labeling yours and you're like, now what are those other 3 again? They're on the backboard up there in the middle at the top. We've got a book page, a couple of worksheets. So it's 2 book pages and 2 worksheets is what it's going to be in total. And then again, if you want to do the extra credit on the back of the complex numbers help sheet, that's absolutely fine. You can get that for extra credit. The one thing I did not put on here that I want to, I wrote it on the board, but I'm going to put it here to help remind some of you. You can also skip number 46 because that went a little bit outside of our realm for what we've done on here. And we'll get some wiggle time in for this a little bit tomorrow too with what we're working on with factoring.